Hello student, today I am going to discuss total internal reflection. What is total internal reflection? The phenomenon of reflection of light when a ray of light traveling from a denser medium to rarer medium is sent back to the same denser medium provided it strikes the interface of the denser and the rarer medium at an angle greater than the critical angle is called total internal reflection. Now you see the diagram. As we know, when ray of light travels from denser to rarer, after refraction, the refracted ray moves away from normal. Again, if ray of light travels from rarer to denser, after refraction, it moves towards normal. Here, since ray of light travels from denser to rarer, so ray of light after refraction moves away from normal. Say this ray if you take, so after refraction, angle of incidence I1, angle of refraction R1, so it bends away from normal. Again, if we increase the angle of incidence, say I2, then it more bends away from normal, so angle of refraction becomes R2. If we increase in this way angle of incidence, the particular angle of incidence, that angle of refraction becomes 90 degree. Since it's moving away, refracted ray moves away, so once it becomes parallel to the interface. So the angle of incidence in denser media, it is called critical angle. I equal IC, angle of R equal 90 degree. Again, if we further increase the angle of incidence, which is greater than critical angle, that is I, angle of incidence I, which is greater than critical angle IC, then ray of light will not be refracted further. It reflected back in the same medium. So this phenomenon is called total internal reflection. There are two conditions of total internal reflection. So conditions for total internal reflection. Number one, the ray of light should travel from a denser to a rarer medium. Number one, ray of light should travel from a denser to rarer medium. So total internal reflection takes place if ray of light travels from denser to rarer, denser medium to rarer, then total internal reflection will take place. Number two, the angle of incidence should be greater than the critical angle. For the given pair of media. So angle of incidence, second condition is the angle of incidence should be greater than the critical angle for the given pair of media. So if these two conditions are there, if these two conditions takes place, then there will be total internal reflection. Now I want to say what is called critical angle. Critical angle. The critical angle for a pair of media is defined as the angle of incidence in the denser medium for which the angle of refraction in the rarer medium becomes 90 degree is known as the critical angle for the denser medium. You see the diagram, already I have explained about critical angle. So this ray, this one, the angle of incidence is I and angle of refraction becomes 90 degree. If angle of refraction in the rarer medium is 90 degree, then angle of incidence in the denser medium is called critical angle. Now we are going to make a relation between refractive index and critical angle. According to Snell's law, refractive index of a rarer medium 1 respect to denser medium 2 and 1 to equal to sin I by sin R. Since ray of light travels from denser to rare, so refractive index rare medium with respect to denser medium is denoted by and 1 2, which is angle of incidence I sin I by sin R. So when the ray of light is incident at critical angle, that is angle of incidence is critical angle I equal to IC and R equal to 90 degree. Again you see the diagram. Here angle of incidence I equal to IC and angle of refraction is 90 degree. Therefore, N1 to equal to sin I equal to IC, critical angle IC, R is 90 degree, sin 90 degree, sin 90 degree is 1, so that is sin of IC. Since N12 into N21 equal to 1, so N12 we can write 1 upon N21, so 1 upon N21 equal to sin of IC, N21 equal to 1 upon sin of IC. So here the ray of light travels from rare to denser. So if you write rare to denser, it will be 1 upon sin of IC. If you write denser to rare, then it will be sin of IC. Refractive index rare to denser and the sin of IC. Denser, this is refractive index here with respect to denser medium, the sin of IC. A refractive index denser medium with respect to air medium, the rarer medium, the N21 equal to 1 upon sin of IC, which is the required expression. That is the relation between refractive index and critical angle, which is N21 equal to 1 upon sin of IC. Thank you.